This video covers chapter 19 from the GCSE textbook, and it's to do with combined events. Now, the best way to display combined events is using a tree diagram. Okay, so a tree diagram is going to show the different outcomes you can have and their probabilities. So for example, let's say we had a dice and we put on here that we can either get a 6, so let's say here I'm going to put this is getting a 6 on a dice, and over here is going to be not getting a 6 on a dice. Now I know that getting a 6 on a dice is going to be 1 out of 6, so I know that this one is going to be 5 over 6. So we always know that when we have like these pairs of probabilities here on a branch, they always add up to 1. So even if I just had one of them, I can easily work out one of the others. Okay, so let's say that I roll 2 dice, and the first bit of this tree diagram is going to represent dice number 1, and the second one's going to represent dice number 2 down here. And let's say again I'm looking at the probability of getting a 6 or not getting a 6. Now these are going to be the same, not 6 here. So these probabilities here repeat, so I'm just going to put 1 over 6, 5 over 6, 1 over 6, 5 over 6. Now when we draw a tree diagram like this, we're able to work out probabilities by like multiplying, adding, because these events are independent. Now what does independent mean? Now independent basically means that one outcome does not affect another, does not affect another. Okay, so basically the probability of me getting 6 on one dice is not going to affect the probability of me getting a 6 on another dice. Now, the way that these probabilities work, if I'm doing calculations, is if I go along a branch, then I multiply the probabilities along that branch. You'll see some examples in a moment. If I go along multiple branches, okay, so if I have to do multiple branches to find the probability, then I still multiply, but after I've multiplied what I get from each branch, which is the same as this, I then add the results of what I get from each branch. So for example, let's say I wanted to work out the probability of getting 2 6s. Okay, so that's a probability of getting a 6 on both dice. So that's going to be, I'd be going along this branch, a 6 on dice number 1, followed by a 6 on dice number 2. That's 2 6s. Now can you see that I've passed the probabilities 1 6 and 1 6, so I'll multiply those together. So probability of getting 2 6s is 1 6 times 1 6, which is 1 over 36. That's the probability of getting 2 6s. Okay, what if I wanted to work out the probability of let's say I get a 6 on dice number 1, 6 on dice 1, and I get a not a 6 on dice 2, not a 6 on dice 2. Right, so let's have a look at which part of the tree diagram I go along. So a 6 on dice number 1 is going to be going along here, and then not a 6 will be going along here. That's a 6 followed by not a 6. Can you see that I passed the probabilities 1 6 times 5 6? So now what I do, 1 over 6 times 5 over 6, So that give me 5 over 36. Okay, let's try another one here. Let's say I wanted to work out the probability of getting a 6 on one dice. So not on dice number 1, on one of the dice, and not a 6 on the other dice. Now, because I haven't specified dice number 1 or dice number 2, I have choices. It could be that I get a 6 on dice number 1, followed by not getting a 6 on dice number 2. Or it could be not getting a 6 on dice number 1, but getting a 6 on dice number 2. So can you see I went along two branches, one I highlighted in orange, one I highlighted in green. So that means when I do my calculation, I'm going to work out branch number 1, what's in green, by multiplying 1 over 6 times 5 over 6. I still multiply for the other branch that I took, which is the orange one, and that's going to be 5 over 6 times 1 over 6. But going back to what I said before, if we go along multiple branches, which I wrote up here, multiple branches, you multiply then add. So let's change that word to then rather than the add. So can you see I've got this addition sign in the middle here. So this is root number 1 that I can take. This is a different route that I can take, multiple branches. You add the results of those multiple branches together. So if I work that out, that's going to be 5 over 36 from the first branch, plus 5 over 36 from the second branch, leaving me with 10 over 36. Now we could simplify it if we want to, you don't have to. If I did simplify it, I would get 5 over 18. Now sometimes you get problems where it's called, you might see the phrase not replaced. Something is taken out and not replaced. Okay, this is where we get to this type of problem here, where we can work out the probability when each event changes depending on the previous event. Okay, let's say that I had 4 green beads and 3 red beads. Okay, and they're in a bag. 3 red beads in a bag. And let's say I take out a bead and don't replace it. So we don't put it back, don't replace it. And then I take out a second bead. Then I take out a second bead. So what we're going to do here is we are going to draw what this tree diagram looks like. Now to help us out, I'm going to draw like a little bag here, and I'm going to draw 4 green beads, 1, 2, 3, 4, and 3 red beads. So 1, 2, 3. And I'm going to draw a tree diagram to represent what's going on here. So when I take out my first bead, it can either be red or green. So the probability that I'm going to take out a red bead, well, there are 7 altogether. So this will be 3 over 7 and green will be 4 over 7. So let's say I go down the red branch of my tree diagram. So let's say I go down this bit here, which means I take out a red bead. Now if I take out a red bead, I'm going to take one out. Let's now look what these probabilities are going to be. So can you see when I've taken a red bead out, there's now only 6 beads left. Now only 2 are red, so 2 out of 6. and for green beads there are 4 out of 6. Okay, now let's do a bit here, red, green. Now let's say instead of taking out a red bead, I took out a green bead. So let's put this red bead back. So we're basically going back up to the top here. But if I go down this branch, this means I take a green bead out. So let's take out a green bead and see what the probabilities are now. So the probability of it being red is now 3 out of 6, or a half. And the probability of it being green is also 3 out of 6. Now can you see how these probabilities here are all different? These probabilities are not the same as these ones or these ones. Not like the previous example where on the second set of trees or branches they were the same as the first, and the probabilities were the same on both sides. These change depending on what happens before. Now just like before, we can use a tree diagram to work out different probabilities. So let's say, for example, I want you to know the probability that I pick 2 red beads. So that means a red bead followed by another red bead. So that's 3 over 7, that's a probability of picking my first red bead, times by 2 over 6, that's a probability of picking my second red bead, which would be 6 over 42. Again, you don't have to simplify it. Okay, let's work out the probability that I pick 2 green. So that'll be going down the other branch, which is 4 over 7. And then I would pass the other green, which is 3 over 6. And that would be 12 over 42. Let's say now I had this question, the probability that the beads are the same colour. Now if I'm going to pick 2 beads the same colour, I'm either going to pick red followed by red, or I'm going to pick green followed by green. This means I take 2 branches. So the red branch is going to be 3 over 7 times 2 over 6. Okay. Now because I'm taking another branch for green, I'm going to add to that 4 over 7 times 3 over 6. So that will be 6 over 42 plus 12 over 42, leaving an answer of 18 over 42. One more. Let's say I had a question that said, what's the probability I pick 2 beads which are different colours? Now if I'm going to pick beads which are different colours, I'm either going to be picking a red followed by a green, or a green followed by a red. So red followed by green is 3 over 7 times 4 over 6. So that's one branch. And the other branch that I'm going to go down is green followed by red, which is 4 over 7 times by 3 over 6. So that gives me 12 over 42 plus 12 over 42, which gives a probability of 24 over 42. Actually, I'm going to do one more, and this one's going to be the probability that I get at least 1 green. Now if I'm going to get at least 1 green, that means I could either get just 1 or 2 greens. Now if I get just 1 green, it either means red, I'll just use letters now, followed by green, or green followed by red, or if it's at least 1 green, I could get 2 greens, or green followed by green. So here there are 3 branches that I'm going to be going along, and I need to work out those probabilities and add them. So red followed by green, then green followed by red, so that's 1 green, or green followed by green, which is basically going to be this root here. So I'm going to multiply along those branches and add the three results together. So that'll be, let's do the orange one first. 3 over 7 times 4 over 6. Okay, that's one branch. Now add to that the one that's highlighted in green, 4 over 7 times 3 over 6. And then for the last branch, that's going to be the green one, 4 over 7 times by 3 over 6. So I'll multiply them and add them in a little space I've got. So I'll have 12 over 42 plus 12 over 42 plus 12 over 42. That will leave me with 36 over 42. Now, one of the other things we need to look at is a frequency tree. Okay, now a frequency tree diagram doesn't have probabilities on it, it has numbers, frequencies. So let's say there's a factory. Okay, a factory, and let's say it has 400 workers. Okay, and let's say out of those 400 workers, 55% are male. Okay, which means that 45% are going to be female. Okay, 45% female. And let's say out of the male, 20% of the males are under 30. And let's say that 50% of the females are under 30. And what we're going to do, we're going to represent this in a frequency tree. So it looks like a tree diagram, but we don't put probabilities on it, we put numbers. So we have our males and we have our females. So we start with like 400 of them, don't we? So the males we have, and actually I probably need to be doing it the other way and put the names here at the side. So we'll put males here, females here. So 55% of 400, let's work that out so we can work out what to put on the males. So 55%, 400 is 220, so you've got 220 males. Now if I take that away from 400, that means that there's 180 females. Now the males and females are split up, aren't they, into under and over 30s. So let's put down here under 30, over 30. We'll do the same with the females as well. Under 30s here and over 30s here. Right, so we now need to work out 20% of 220. Let's write these percentages on. So 20% are going to be under 30, which means that 80% of the males are going to be over 30. 45% of the females are under 30, which means that 55% must be over 30. So now we're going to work out the percentages of these values. So let's work out 20% of 220. So we can do 0.2 times 220. So that means that 44 of the males are under 30. I'll work out 80% of 220, or I could just take 44 away from 220, I get 176 here. Then for the females, I need to work out 50% of 180, well that's 90, and 90 here, yeah? Now once I've got that information, I could just work out probability. So for example, I could work out the probability, let's say that a male is over 30. Well, there are 400 people altogether, so it's out of 400. And there are 176 that are over 30, so there we go. What if I wanted to work out the probability that it was a female under 30? Well, again, it's out of 400. And how many females are there under 30? There's 90. So these are the probabilities here using this, what we call frequency tree. And let's say I had something like this, where I'm just looking at the females, for example. So a female is chosen at random. Okay, what is the probability? What is the probability they are under 30? Now, if a female is chosen at random, it's not out of 400 anymore, because we're just picking from the females. It's only out of 180. Now, how many of those 180 are under 30? It's going to be 90. So here it's not out of 400, it's out of 180 because of the wording. A female is chosen at random. So you're just choosing from the females. So watch out for questions like that, because that will change what you have in the denominator. So to recap and to maybe go over some of the other points we haven't looked at, if you see, and this will go over this bit here, and an or, if you see the word and or both or together in a question, that would normally mean that you multiply the probabilities to get the answers. So you multiply probabilities. If you see the word or, something happens or something else happens, then you add the probabilities. Yeah, and we can do this because these events are independent. Okay, and the only other thing you need to watch out for is when we have things where it says something is taken out and not replaced. So beads in a bag, cards, that sort of thing. If something is not replaced, okay, the probabilities will change. So the probabilities change in the tree diagram.